chloride here. Today I'm going to show you an OTC method for obtaining the salt potassium ferrate. Over the past year I've been basically losing my mind over trying to make this compound. I've tried dry chemistry methods involving ignition of a mixture of iron powder and potassium nitrate, which only yielded a tiny amount. Of course, absolutely nowhere close to anything I could isolate. I've tried wet chemical methods, such as the oxidation of iron 3 hydroxide with sodium hypochlorite. That produced nothing. I've also tried electrolysis, but I didn't get anything from there either. All this time, it's been sitting on the shelves at a store that I go to all the time. It looks like this. Wound seal. They come in little tubes in a package, and they're meant to stop superficial bleeding on the skin and sort of create an instant scab. They come in packs of 4, but I only have 3 because I tried this with my first one. On the MSDS, they say that they contain a hydrophilic polymer and potassium ferrate. Both of these are solid. It's a powder. So, what I'm going to do today is show you how to isolate it from the polymer and turn it into the barium salt, which is substantially more stable in air than the potassium salt. Oh, I should also mention that I purchased these at Rite Aid. I'm not sure if they're at, stores like CVS or Walgreens. As I'm in the United States, it's probably different in places like Canada or Europe or Australia. But I did find these at Rite Aid. They probably are at Walgreens, but I'd just check to make sure if I were you. Alright, first we're going to need to make a cold basic solution. How I'm going to do that is by adding water to a small beaker until it reaches about 80 milliliters or so. That's about good. Then I'm going to add a few ice cubes. I should also mention you should be wearing gloves while doing this because potassium ferrate does attack the skin. And the solution we're going to be working with here is basic, so that will also attack the skin. Add the ice cube to it, and I'm going to let it cool down for about 30 seconds to a minute or so. Okay, now that that's cooled down, I'm just going to add a bit of sodium hydroxide and dissolve it to make a relatively basic solution. You don't want it super concentrated, and you don't want it dilute either, because then your ferrate will decompose pretty quickly. So, not a ton, just a bit. A few grams probably will do you just fine. And just going to dissolve it. It'll evolve some heat, as that's what happens when sodium hydroxide dissolves into water, but that's what the ice cubes are there for. You don't want your solution to be too hot, that can also decompose the ferrate. So I'll come back when this is nice and cool and all dissolved. Alright, everything's dissolved now. I'm just going to add probably one more ice cube just to make sure it's nice and cool, because those ice cubes are gone now. Alright, just make sure you also have something to stir it with. That will help dissolve the ferrate. Alright, next we're going to want to take our tubes of wound seal containing the potassium ferrate, remove all the caps, and they'll have a little foil seal on them. I suggest just cutting them off with a pair of scissors, like so. This will just help you get the most out of the package. Make sure everything's at the bottom. And that's what it looks like. Sure everything's out, and I'm going to do the same thing with the other 2 tubes. Alright, now that you've done that, you're going to end up with a powder looking sort of like this. Sort of reddish, rustish looking color, but that's mostly the potassium ferrate mixed with the polymer. I don't know if the polymer is brown or not, but it could be. So, Now what we're going to want to do with this is dissolve it in our solution of sodium hydroxide. Alright, here we go. As this powder dissolves, you'll hear a slight like hissing sound or fizzing sound. I think that that's just the polymer heating up when it touches water. So, here we go. Now adding the ferrate. And working quickly, I'm going to dissolve that. So we get a nice deep red solution, which is basically screaming, "I'm ferrate," at you. So just going to make sure everything's dissolved, everything's out of the filter. And we'll go ahead and make sure that it's mixed completely and dissolved. If you want, you can wash out these little tubes with water and then add it, but there's really not much left in there, so I wouldn't really say it's completely necessary, but it might improve your yields if there is a little bit still stuck in there. Alright, next you're going to want to filter this mixture into a larger container, such as a larger beaker. Here I have a 500 milliliter beaker. Should do you just fine. You could get away with the flask too, I'm sure. Wet paper. And then filter your mixture. You'll get a red solution of ferrate. And so come back when everything's filtered. Alright, well that's filtering. We're going to need to make a barium chloride solution. You can do that just by dissolving an amount of barium chloride in water. Here I already have a pre-made mixture. That should do about good. And when the ferrate is done filtering, we will combine the two to create the solid barium ferrate. Then we'll filter that, dry it, and observe the product. Alright, now that the ferrate solution is done filtering, I'm going to add directly to it our solution of barium chloride and water. Mix. It won't be immediate, but over a period of maybe a few minutes or so, you'll see the barium ferrate precipitating as solution as sort of a brick-colored solid. You can already start to see it now. And the solution will become less and less red-colored. Just going to leave that there for a few minutes. Alright, now you can see against the white background. You might not be able to see it on camera, but it's definitely evident from my point of view. It's sort of light burgundy colored powder. That is our barium ferrate, and while that's precipitating, I'm just going to explain what's happening. So basically, we got the potassium ferrate in a solid form mixed with the polymer from the wound seal. Now that undergoes a double displacement reaction with an equal amount of barium chloride to produce potassium chloride and barium ferrate. So that's a double displacement reaction. Barium ferrate is insoluble, precipitates. Potassium chloride is soluble, and it dissolves. So you can, if it makes you more comfortable afterwards, treat your filtered solution with a sulfate salt after you filtered off the barium ferrate to make sure there's no barium soluble barium left, because that is very bad for the environment and also very bad for you. So I would suggest that, but in the end it's up to you. Alright, now we just have to filter it and we get our barium ferrate. Alright, here's what some dried product looks like. Like I said before, it's a sort of burgundy powder. On the camera it looks a little more pink than it really is. So it's more of a brick color, I'd say, but this is just a little bit from a previous run I did. Let me go get some that I did from a dry chemical method that I did a while ago. Really the only one that's ever produced, even a small hint of ferrate. Still, this is the best method for obtaining it in my opinion, but let me go grab that and show you what it looks like after about a month or two in storage. Alright, here's what the old stuff looks like. As you can see, pretty much the same. I think it becomes a little darker when it's more finely crushed up, but this is barium ferrate from about a month and a half, 2 months ago. Still doesn't really seem to show any signs of decomposition, but I'd probably, if I were you, I'd keep it in a vial like I do, just to prevent any, possible oxidation or decomposition. So, yeah, that was the, extraction of potassium ferrate from an over-the-counter product and the subsequent conversion into barium ferrate. Really hope you enjoyed. You can subscribe if you want to, like if you want to, and thank you very much for watching. I appreciate your time.